All right, so here would be just a sample of how you would use those two theorems. What will most likely happen is that in an FRQ, one of these theorems might be like part B. So you have what's called the stem of the problem. So the stem is the part that you're given. And then parts A, B, C, D, those are all called the branches. Each branch will ask you something different. It could be from first semester, it could be from second semester, it could be about a theorem, but you have the stem you're working off of. So here would be a stem. The stem would be, this table represents a continuous and differentiable function, which means you're locked into all three of the theorems. So then using those values and looking, okay, I have one negative value and I've got the rest are positive values, and looking at kind of the direction, justify why there must be at least one time that f is equal to 4. What theorem are we using if we're talking about f being equal to 4? IVT. Okay, this is IVT. Can you justify whether it means at least one time that f is equal to 4? Can you find it for me? Yeah, Zach.
Can you say on the interval x equals 3 to x equals 0?
Okay, 3 to 0?
Negative 3 to 0.
Okay, give me your case.
Because f of negative 3 equals negative 1, and f of 0 equals 5, and 4 falls in between that interval.
Yes, okay, so that's one thing you can do. Okay, so the due to continuity, so by continuity, since we've got it, the IVT guarantees that f is equal to 4 on the interval, he says negative 3 to 0, because f of negative 3 is equal to negative 1, and f of 5 is equal to 4, equal to 5. And f of x equals 4 would be between. Oh, whoops, yeah. I wrote it wrong. Fix this between. There we go, negative 3 to 5. Okay, that's at least one. Is there any more? What did I do? Oh. Okay. Any more? Okay. Now, yeah, go ahead.
The intervals of 2 to 4.
Okay.
Because f of 2 equals 7, and f of 4 equals 3, and f equals 4 is equal to those.
Okay, great. All right, so same sentence, only replace the 2 and the 4. That'd be another interval, okay, because 4 is between those two endpoint values of that interval. So if you narrow your interval down, you are guaranteed, so you could say the exact same thing. So we were guaranteed at least one, and in fact, we found 2. There could be more. We just don't have enough values to prove more, but we could prove at least 1. Okay, yeah.
For the AP test, we don't put IVT, but explain everything else.
Like you don't name the interval. Yeah, name the theorem, you mean? That's fine. Like if you blank on the name of it. Helps to name it, and you can name it by letter. You don't have to spell it out. Okay, now last one. Justify why there must be at least one time that f prime is equal to 4. So here should be the combination of we have differentiability and we have f prime, which means we're using what theorem? MVT. So you would say by continuity and differentiability. Okay, so we've got both. The MVT guarantees that f prime of x, which is going to be an f of b minus an f of a over a b minus a, must be equal to 4. And again, that should happen at least once. What I need you to do is find me where that happens. Okay? Find me where that happens. Yeah?
0 to 1.
0 to 1. Okay? On 0 to 1, f of 1 minus f of 0 over 1 minus 0 would be 9 minus 5. And now we've just justified that that must be true at least once. Does it happen any other time? Not on this data set, okay? Might happen another one, but it only happened not on this data set. So you got your at least one. Yeah, Blaine.
But 0 is less than x is less than 1. Would it be fine if I just wrote that in brackets?
Yes, yes. Can you use bracket notation? Sure. Yeah,
And you only have to show it once if it
Yeah.
appears twice, you only have to show it.
correct, correct. Okay.